Hi everyone, welcome to the session. So in this session, typically we're looking at this question. It's an interesting question, a little bit difficult. Can be said a moderately difficult question type. Now, let's delve into it. The question says that f of x is a quadratic function. It attains a minimum value of minus 0.25 at x equals to 1.5. At x equals to 0, the value of the function is 2. Find the other value of x at which f of x is 2. Now this was, I think this was a decently difficult question because, in a test setup, it might appear a tad bit more difficult. So first of all, let's appreciate certain things about the, question itself. What is the, if I ask you what is the graph of a quadratic function, obviously it's a parabola. Now because the parabola or because the graph attains a minimum value, I can assume that it is a upward parabola. Okay. Now, one more thing I would like to ask you, that the parabola attains the minimum value at which point, which is x equals to 1.5. Now, this x equals to 1.5 is going to be a little important for our purposes because it is about that point we will find the line of symmetry. Now, this is typically called the line of symmetry. Okay. Now, we don't really need to go too much into the details of what line of symmetry and all that is. It is basically a line that passes through the critical point, which is 1.5 for our purposes here. X equals to 1.5. Obviously, needless to say, it is going to be perpendicular to the x-axis. The idea is that any point that you take, suppose we take this point, let me change the color. So let's say we take this point. These points will always be equidistant from the line of symmetry. That is all that we need to understand from this question. Okay. So in this question, it is given that at x equals to 0, the value of the function is 2. Okay. So at x equals to 0, so suppose I'm drawing another set of lines. So let's say, these points itself, this point and this point. Okay. They may not look very much equidistant, but then we are doing everything freehand, so please appreciate that. These points, here it is written, at x equals to 0, the value of the function is 2. Now what does this mean, value of the function equals to 0? It only means that when you plug in at x equals to 0, the y coordinate will come out to be 2. In other words, I know that this point, suppose I call this point as a, this is 0, 2. And the question now boils down to what is question mark, comma 2, because this is going to be, parallel to the y-axis. So the points, the y coordinates will be equal. Okay. Now you don't have to really put any distance formula or anything or that sort. The same idea which I just now mentioned, that these lines are going to be equidistant, or these points rather are going to be equidistant from the line of symmetry. Now you have remembered that this blue line is the line of symmetry. So you have to tell me the answer now. The answer is 0 to 1.5 is a distance of 1.5, and from 1.5 obviously the other distance is going to be 1.5. So from 0 it will be 3. So the x coordinate will be 3. The answer to this question is 3 itself. Now this was very easy if you do it graphically. If you try to do this question traditionally, then there are a few pitfalls. For example, you will have to assume some values. For example, let's say I give it a shot. So these points I don't know, but I have to assume that these points are at a distance. Just now I mentioned that they're going to be at a distance and equidistant from the line of symmetry. So we will have to assume some value. So the points can be assumed as alpha is equal to 1.5 minus m, and beta can be taken as 1.5 plus m. Now, at this point, how is it that we form a quadratic expression or an equation or a quadratic function in general? We can write it like f of x is given as x minus alpha multiplied by x minus beta. This is the general form of a quadratic expression. Now, please remember, in the question it is given that at x equals to 0, the value of the function is 2. What does this mean? That you just need to substitute f of 0. That will be something like this. I am changing the color. F of 0 will be, now I am putting 0 and 0. So this is minus alpha into minus beta, that is alpha into beta. So alpha into beta, which in turn is given as 2. Now hold on. a plus a minus b, a plus b, that is a square minus b square. I can directly write it. 1.5 ka square is 2.25. Okay, 2.25 minus m square, that is equals to 2. This implies that m square is equal to, I'm directly doing it, 2.25 minus 2 is 0.25. This implies that m is equal to 0.5. Okay, now hold on. At this point somebody can say, but sir, it is given that this point is, the x coordinate for this point is 0 and not 1, because you know, if you go leftwards of 1.5 you'll find 1. At this point I would like to say that the, you know, it is not the answer. M is equal to 5 is not the answer. It is not the x coordinate also. What it is you just need to substitute that value and you'll get the function fx as x minus 1 and x minus 2. This is the function f of x. Now do you remember that these functions are actually, you know, equal to some value? F of x is given as equals to 2. Now x minus 1 and x minus 2 is equals to 2. Now at this point I don't think you need me, you can directly do it. X minus 1 equals to 2, x is equals to 3, and x minus 2 equals to 2, that means x equals to 0. Now this is a more textbookish way of solving this problem, but I would rather you solve it graphically than go about the question like this. This was good for understanding the question, but really not you know, necessary in a test setup, because it will unnecessarily eat up a lot of your time. So yeah, I hope you enjoyed this video. If you did, you know the drill, like, share, subscribe. Yeah, thank you.